Yeah, a lot of fans make a joke about me about who is who. Okay. Okay, I shouldn't speak too much because we have excellent experts today that will share their thoughts about AI robotics. But today, I think we are all here with the exhibition. We will try to find out what is the growing path of AI combined with robotics. So here are my 2 cents of ideas, and I want to share with you. Okay. So we should start also from what all the managers or the corporate owners, they concerned about the cost, added value, rights, and the ethics when they run the company. And all the technology lending has to circle around all those objectives, okay? But in the past, I think in the past 10 to 15 or 20 years, digitization has already entered our society and also a lot of industries. So if you look at from the left-hand side, the supply chain all down the way to customer relationship or the CRM, all these all the steps has been digitized a lot. Of course, there are a lot of companies still trying to make the digitization or a lot of information technology enter the company to help. Okay, so I think that, for example, Industry 4.0 is one of the ideas of digitize all the industrial activities. However, what we are facing today is the last mile, what I say the workforce resilience, okay? Many of the activities are still handled by human, okay? But we will have we call aging society, and of course in Taiwan, we have a decreased newborn baby. So how are we going to maintain the economic growth? So that is the main concern, okay? But how do we fill the gap of this workforce shortage? I think in the past, a lot of automation technology already tell us that we can replace human or help human in a lot of activities, like in the industry, in the factory, when handling heavy objects. Then we can use a very big robot, okay, to handle all the, for example, in automotive industry. Okay, so a lot of automation technology already enter our manufacturing or even in the service domain, but that's not enough. Okay, on the right-hand side, you can see what is the demand. These demands are still unfulfilled. First one is a skill-intensive manual task. We still have rely on a lot of manual skills to produce a product that we want, and those skills are owned by some person, and those persons become older and older, and nobody are willing to take over these skills. The second one is environmental adaptivity. The reason is that when we introduce the automation, the first thing, the easiest one to do is to re-engineer the shop floor, re-engineer the environment to fit the automation equipment, but that will cost a lot. So can we produce a technology that we don't need to change our environment? Then we can introduce the automation into our production line or the service environment. That's very important. And the third one is local, no-code programming. This is very practical. Okay, when we install the robot, currently we still need the engineer to program those robots. And those engineers has to be well-trained. And those workforce are very limited. Okay, and you train the engineer, you require experience. You cannot have a freshman graduate from college, then he can know how to program the robot efficiently. Okay, the last one, but the most important one is event handling with minimum disruption. Okay, of course, in the automation line, when you have some glitches, then it will cause the automation line to stop. Then you will lose money. Then you will have people rush into the production line to see what happened and how to solve the problem. Okay, those things are very serious in our production efficiency. So that's why the AI technology introduced with the robot, we try to solve this problem and give a better production or service environment. I think a lot of experts, at least here, and not not all, but many experts already in their speech or in their articles, you can see a lot of them emphasize on what I said above in the previous slides, okay? And later on, I will introduce some of them. But of course, we have the objective, and we know what we are going to do. But there are still a lot of technical difficulties, okay? AI is one of the, I would say, they shed us light. You see, we follow the path. Maybe we can solve all the problem we concern a lot, okay? And so in the previously, we have a lot of industrial robot arms, collaborative robot, and they introduced a lot into our industry. But most of them are designed for simple and repetitive tasks. They can do things very well if they are repeated and with a precision, with a speed. They are doing very well, okay? And gradually, you can go to the right-hand side. What we are trying to solve is just like the previous slide I said, we are not targeting on those repetitive tasks. We are targeting on the flexible and the complex tasks, okay? So we need more intelligent robotics and with a lot of degree of freedom. For example, humanoid robot, multi-legged robot, so they can adapt and maneuver and very easily in our natural environment. And those we combine with the AI, maybe this is a way we solve all the problems we face. Okay? So a lot of market trends, I'm not going to say in detail, but people say this is a very promising industry. The AI robotics, not only the new type of robot, but the traditional industrial robot and the current service robot, the growing potential is huge, okay? With the introduction of AI to solve the problem, okay? So the fundamental difference of the AI robotic from the previous robot is autonomy and automation, okay? When we try to do things, we first come up with an objective. Then we have to have an action plan. Then we execute them, okay? Previously, in automation, the action plan was designed by human. Okay, so you program the robot with a repetitive path, and you program it, then the robot repeat the path, repeat the task many, many times with very high precision, okay? But the first step of introduction of AI is the robot will plan itself. It means the robot will have the action plan. For example, automation task generation, robot workflow planning, path planning, control programming, or mapping the environment, localize, and navigate around the environment. Scene understanding, for example, when you see things, oh, this is a chair, okay? I can move the chair, okay? This type of understanding, object recognition, grasping, and manipulation, there are a lot of companies focus on this area right now, so that when the robot do things, they don't need to be programmed. They see the object from the vision, then they know how to manipulate the objects, okay? And a multimodal human-machine interface, we are no longer using the keyboard or mouse. We can speak directly to robot, so he can understand and respond to our command. And skill learning and transfer. This is some of the companies in this today's exhibition. You can see that they're trying to teach the robot how to do the skills, not just a simple pick and place tasks. So in order to do that, on the left-hand side, we can see a lot of models. A large language model is already very popular. Then right now, currently, I think like Fei Li in Stanford, they try to solve the large world model. It's a model that can understand the world, okay, without teaching the robot. And the large behavior model is a model that the robot will do the manipulation by itself. He knows how to do the manipulation. For example, he sees the egg. So the robot will see, okay, I cannot use too much force. I know I have to use my tactile sensor in order not to crash. the egg. Or those type of behavior model is a model are we trying to build. Okay, so there are a lot of architectures that will structure on the future of the robot. For example, but it's like a mimic the human. Okay, we have a brain and a cerebrum. Okay, the brain is doing the logic thinking, inference, understanding the world, the process our information. But we have a cerebrum that has to control our body, okay, to come up with appropriate action to achieve a goal. So recently, if you see the development of China's robot, they all focus, a lot of focus on cerebrum. So the robot can dance, the robot can doing the boxing, whatever. And they use the AI to train their cerebrum, okay? So there are a lot of challenges trying to build this cerebrum and the brain. But from my understanding, the technology to build the cerebrum is more or less much mature right now. Maybe 2 years or 3 years later, you can easily train the robot, multi-link robot, to do a lot of actions. However, the brain technology is very much very difficult. Just like I said, what is the world? How do we build the world, idea of the world to the robot? And how do we equip the robot with the behavior that can accomplish a lot of work we are doing right now, okay? So let me say it again, the large behavior model. This comes from 1980s. You know, if you know Dr. Moravec, he's a professor in Carnegie Mellon University. In 1980s, he already said that from this one, computer can generate better at performing high-level cognitive tasks than human. But when dealing with the low-level perception and the motor skills, the computer is far inferior to human, okay? So the computer can do a very complex computation, mathematical, physics, computation, whatever, but when it comes to the regular daily behavior and task, the computer are inferior to human. That's the 1980s. But all these years, the technology progression, for example, the high computing power, the massive computing power, and the advance of artificial neural network, maybe they'll try to break this dilemma, okay? So, for example, in this one, I would say, you can easily tell somebody, say, okay, put the scatter tool in the toolbox. You don't have to describe what are the tools. You don't have to describe what is the toolbox. But the human, when he receives the command, he can easily generate the actions. He can easily understand, okay, what is the tools, what you are talking about, what is the toolbox. And you don't have to tell him which tool go to which box. He can easily figure out by himself, okay? But if you try to tell a robot to do so today, it will be a headache, right? You will do a lot of complex programming unless the robot understands what is the tool, what are the tools, what are the boxes, what is the action of putting tool into the box. And those are the artificial intelligence combined with the robotics. All the experts in the startup company, they're trying to do so. Okay, this is the trend. Okay, and how do we do that? The first one is we call learning by demonstration. It's like you teach another human, right? How to do this, then you just do it again once, then he saw this, then he repeat what you are doing. Okay, this is learning by demonstration. But this could require a huge cost because you need to construct the learning system. You try to tell the robot what to do, okay? So for example, Toyota Research TRI and the Stanford Aloha project, there are many projects that are doing the learning by demonstration. But people say this is cost too much and too slow. So a company like NVIDIA or some other company, they try to do the simulation base. Simulation base, you create a sim to real environment. In other words, in the computer space, you build a very high fidelity environment to mimic the real environment. Then you put the virtual robot there and you try to teach the robot in the virtual space. If the robot is mapping 100% one-to-one mapping to the physical robot, Then after learning in the cyberspace, the robot can transfer the skill to the physical space. This is another trend. But how do we teach the robot in the virtual space? There's still a lot of techniques. One of the technique we call reinforcement learning, right? You've saw a lot in a lot of reports. So people try to develop a lot of reinforcement learning. Of course, this is the power of this cyberspace simulation is that you can have millions of robots and the environment in the cyberspace. So he can easily, very fast, to try every type of skills. And so this is a very, I think this is an exciting trend that we can teach robot in the cyberspace and the map to the real space. Okay, so this more or less, I'll tell you the what I think about the future of AI robot. Okay, so go back to Taiwan, just like the president said, what are you going to do? Taiwan actually has some foundation, very strong foundation. But in this AI robotic trend, we are still chasing the world leaders. Okay, so we have a lot of machinery company, we have precision engineering, and we have a lot of OEM experience. Of course, we have TSMC, a lot of chips are made in Taiwan. And we have very good EMS company. I think more than 80% AI servers are made by Taiwan. Okay, so we have a very good foundation of developing this robotic industry. So people think this is, and of course, very important. We are the trusted partner of the world, right? Okay, I don't have to tell you more, but we are a trusted supply chain partner. Okay, we don't infringe our customers' value, and we protect our customers' right. This is very important. This is a common practice of all our industry. Okay, so this is what I propose to the government, and I think currently we are following this path. We have two directions and 4 strategies. The first one, we use the AI to value add the current. So in other words, we don't invent a real robot's configuration. We will put the AI in the traditional robot arm or AMR, whatever, so they can create more value based on existing hardware. The second one, of course, is a new hardware, the multi-link robot like humanoid robot or a multi-leg robot. Those robots will target on the new business. So, and of course, in the middle, it's the AI model we try to build. Now, recently we have a lot of debate. What kind of AI model we try to build? Because to build an AI model like a ChatGPT or large language model would require a huge amount of resource. But for robots, maybe we do not need such a large robot if we try to create a specific domain values. So how do we reduce those large language model into a smaller one that can achieve the goal we're trying to do? This is a direction of dealing with an AI. Okay, and the last one, I would like to do some commercial about E3. Okay, E3 developed the robot technology since 2005. 2005 is a long time ago, right? Okay, about almost 20 years. Okay, so we start a very simple service robot, then we migrate to the industrial robot, and during the course we have a spin-off company. One is doing the exoskeleton robot, and the other one is doing the producing the robot skin. Okay, the CEO is in the audience. Okay, with skin. At that time, I'll tell him that in the future, the robot should have skin. A lot of robots have eyes, right? But no robot in the world right now have skin. Currently, right, of course, there are some robot arms, hands with a skin. But actually, the robot should have skin all over his body, because if a robot try to interact with human, touching is inevitable. So he has to sense the touch. So this is one of the company that we spin off in the now. Of course, currently we try we put a lot of resource on how to put the AI into robotics, as I said. Okay, so these are the solutions. I don't want to display too much detail, but first one is on the left-hand side is a robot cell controller that will introduce the AI into the box. The box will coordinate the robot and the machine surround this box with the robot controller. Okay, and how do we handle the workpiece? And how do we simulate the either in the service or manufacturing environment? And how do we equip the robot with skill? Okay, currently our focus is on industrial practice like grinding, polishing, welding. Those are skills that still require human, but we cannot find the workforce right now because of the aging society. Okay. Okay. Whoops. Okay. I don't know if I can make this work. This is some video. This was done several years ago. That on the left-hand side, you can see a phantom robot. Oh, 5 minutes. Okay, phantom robot. So this is like a digital twin. Okay, digital twin. In other words, in cyberspace, we can practice all the simulations and task planning for the robot, and it will map in the real robot. And this is what people are trying to do currently. Okay, the right-hand side is also the robot cell controller, coordinate multi-robot to achieve the same task, one task. And for AMR, there are a lot of applications in either factory or even the convenience store. This is a robot very interesting that we collaborate with convenience store, but currently we are trying to see if this robot can be introduced into a convenience store so that because lack of a human resource also in a lot of our convenience store. Okay. This is the hands that we developed several years ago, and we are trying to make a second generation of our robot hand. Okay, and as I mentioned, one of the most important technologies is how do we establish the world model for the robot. In other words, how the robot can understand, comprehend what is the surrounding environment. So we spend a lot of effort of trying to figure out how to generate this large world model. And I will show you the video because I don't have time. There's no sound, I'll explain. On the left-hand side is the real video. And from using the computer technology, we came from the real the camera image, we produce the virtual environment. The virtual environment mapped to the environment. And one of the interesting is that things is that in the environment you see a microwave, but from the video image you can only see a box. But when you introduce into the cyberspace, we have to tell the robot that this is a microwave oven and it can be opened. Okay, and that's what we call world model. We try to establish the world model. Then once we have the world model, then this is a virtual robot. The robot can manipulate and navigate around the virtual environment and accomplish the task we assign. And you can even learn how to do that. Then they can implement in the real model. This is only an experiment. We try to figure out how do we teach the robot what is the real world and how do we teach them how to accomplish the task in the virtual environment. Okay, so this pretty much share my thought. I hope that this is good enough for you to understand. Thank you.